Hi everyone, welcome back to another live episode of RetFix and Chill. We're here at AAO 2025 in Orlando. We're going to do a little bit of a different twist of our usual episode. As we know, complement inhibition, treatments for GA are a really hot topic right now. We have two FDA-approved treatments for geographic atrophy, and there are a lot of new treatments in the pipeline. Today, I have the pleasure and honor of learning a little bit about the story of complement from Cedric Francois, who is the co-founder and CEO of Apellis. And I had the privilege of hearing the story of complement in ASRS this year, and I think it's a really great story. So it's really great to have you here, Cedric. Looking forward to hear the story of complement.
Thank you so much. It's really a pleasure to be here, and love talking about complement, so it should be fun.
Yeah, tell us the story. How did it all get started? How did you get interested in complement? And how did we get from that initial inspiration to the product that we have available for our patients today?
Yeah, thank you. It takes a long time, right? It all kind of started in Louisville, Kentucky, believe it or not. So I'm a physician by background, and my original background was in plastic surgery, reconstructive surgery. And in Louisville, Kentucky, they did the first hand transplantation in 1999. And I wanted to join that team and work on the research side. And while I was doing my PhD, I started working with a group that was based in Boston, two amazing scientists, one of whom is still our chief scientific officer today, Pascal de Châtelet. And we became really interested in macrophage behavior and really interested in how macrophages contribute to the pathology, potentially, which at the time was, of course, a hypothesis. To the pathology of geographic atrophy. And, as often is the case, we came up with a whole bunch of crazy ideas. It was only three of us. They called us the Three Stooges in Louisville, trying to figure things out. And I love to tell people that we had some kind of a genius thing that we thought about. But what really happened is initially we wanted to change macrophage behavior with a very complicated, complex molecule, which was a reduced antibody with phospholipids on it, etc. And then one day an investor asked us, what is the cost of goods of this product? And we're like, cost of what? Never done it, right? And then we realized it was going to cost $2 million per patient to treat them, like just to make the product. Wow. And we're like, the Three Stooges had to go back to the drawing board. And then one day, we walked through a corridor and saw a poster on complement. And we kind of figured, what would happen if we start controlling complement activation when macrophages interact with their targets. And that was, quite frankly, the original genesis of all of the work that then afterwards came together. So we're talking about 2004, 2005, 20 years of work in the making. The company at the time was called Potentia Pharmaceuticals, which was sold to Alcon in 2009. And then in 2010, we started with Apellis, and we were, at the time, not allowed to work in the eye, only to work with systemic inhibition of C3. And we developed this molecule, pegcetacoplan, which we put in a systemic subcutaneous formulation and started developing it in a range of rare diseases. That product ultimately got approved and is now on the market for 3 indications. It's called Empaveli. But in 2014, we had the chance to go back to our home base in the retina and kind of really refocus on what we could do in geographic atrophy. And it was just a fascinating story because now thinking back and looking back, we were just a couple of people kind of with, fearless, also with not a lot to lose at the time, right? And really diving into that science and taking appropriate risks. In the first Philly trial, which was really the first trial ever to show that complement inhibition could do something in order to slow down geographic atrophy. And then afterwards, of course, all of the clinical work that we did. But for me, looking back today, what I'm most happy with and probably proudest of is the deep commitment and investment that we made at risk with a board that was highly supportive to not half-cut it, but to really, really understand what is going on in this disease. And when you take the Philly trial and you take Derby and Oaks, in which we had 1,200 patients, Philly was 240, then 3 years of a full extension. In February, we will have 5 years of data for about 650 patients that have been followed for all of these many years. Extraordinarily rich data set. And that has taught us so much and continues to teach us. So it's been a great journey and really happy to be here.
It's really cool to see just the sort of inspiration and how there's so much serendipity in the science of it. You just happen to see a poster, right? And now we have the potential to help millions and millions of patients. It's interesting because when I talk to patients about complement inhibition, So as I've grown my practice, I have a private practice. Initially, I had a lot of DME patients, but now it's becoming a larger and larger AMD patient population. And I'm having these conversations about, okay, do I get patient buy-in? And one of the hardest things that I've noticed is it's hard to tell patients that, okay, look, we're proving a negative here. I've heard a lot of conversations about like, oh, this is sort of like glaucoma. It's sort of like diabetes. You may not see a change, but we're helping you in the long run. So, one of the things that people ask is, what are the biomarkers, right? And I'm sitting there with my Heidelberg OCT measuring the transmission defect 2 years ago to today and saying like, hey, look, this has gotten bigger. If we start treating you with this medication, these are the risks, benefits, and alternatives. We know that in 6 months that the rate of growth will be smaller. What are your thoughts on sort of how we can talk to some of our patients in the absence of reliable, established biomarkers?
Yeah. So I think you touch on something really important here, which is that it's hard as a retina doctor to treat geographic atrophy, to explain to a patient what the disease is, to explain how it progresses, what the drug can and cannot do, and then importantly also to track it, right? I mean, if you have patients on treatment and they come back to you after a year and say like, hey doctor, is this working for me, yes or no? You cannot really answer that question, right? And so already a couple of years ago, we started thinking, what can we do to kind of move beyond what we believe is a profound misunderstanding behind what this disease represents for patients? Because there's no functional mapping, right? Forget about the drugs that are on the market. We do not really understand what the functional implication is of having this disease. And that is where we set out on what I think is one of the most exciting projects that we have at Apellis right now. We call it functional OCT, OCTF in short. And what we did there is very, very cool. This kind of came originally out of a concept out of Frank Holz's laboratory in Germany, where the idea, a little bit similar to easy zone attenuation, where you say, can we, based on the structure of the retina, predict what the functional impact would be? Now, the problem that you have with easy zone and things of the like is that they're really structural analyses, and making the leap to function is a big one. And then we realized that in the studies that we did, in the OAK study, and then afterwards in the Gale extension study again, we used the Maya device and used microperimetry to look at retinal sensitivities. And when you kind of think about the Maya device, where you look at one eye and you have 68 dots that you interrogate individually for light sensitivity. If you now think of every dot as a little human experiment, because a human clicks on a button when they see a certain intensity of light, and you then add up all of the dots that we have, 68 dots times 2 eyes, times 600 patients, times all the time points, then we have 200,000 little human experiments. And we said, okay, let's overlay the OCTs, and let's cut out the cylinder of the retina where the light hits it. And now let's find out if we can structurally analyze that cylinder for integrity. And based on the integrity of that cylinder, figure out if algorithmically we can now predict what the light sensitivity would have been had we done it. And that algorithm is now very good. And what that opens up to us is absolutely incredible, right? Because now I can take an OCT and I can map out the retinal sensitivity across the retina, all of it, and the loss that you incur over time. And because it's SD-OCT, I can go back in time, 3-4 years, and say, if I have historical OCTs, right? I can say, this is what it was 4 years ago, 3 years ago, this is how it's been advancing. Beyond that, we can then actually take a stock image and pixelate that stock image to kind of represent what the patient actually experiences and how that has declined over time. And then we went one step further and we're like, okay, what if we can, have a family member experience what this disease represents? And we came up with this augmented reality headset where literally you can have a patient, you take an OCT and ask the son or daughter, do you want to know what it's like to live with your dad or mom's disease? Put this on and run around a little bit. I mean, it's going to, and this touches on something that I think is really, really important. I mean, many of you, all of you, I presume, right? I mean, have patients that come in with geographic atrophy. You look at the last image from 6 months or a year ago, you don't see a lot of change, BCVA is stable, and you tell the patient, you know what, doesn't look like it's progressing a lot, right? I mean, and then the patient telling you, but my vision is much worse. And then, there's no way of quantifying or qualifying that, right? So this will give us that opportunity to rethink what this disease means. It's going to make these patients feel seen by their family members, by you, by the retina, by the treating physicians. And also allows us to really now understand what the impact is of treatment, right? For example, when you treat a patient with Syfovre, in the majority of patients, you're actually going to get an increase in retinal sensitivity, not a slowdown of a decrease, something that you can now quantify. And when patients say, I think I see better, maybe it is not a placebo effect, but something real that you can image. So you'll have the ability to see over time how the disease progressed. We'll be able, with time, to predict where that disease is headed if you don't do anything, what you can do if you go on treatment. And when the patient comes in after a year, you can say, hey, here's the benefit that the drug has given you. You should probably stay on this treatment or not. Whatever that is kind of what we really need. And for me, there were 3 important learnings from the data analyses that we have done. Number 1 is that a lot of retina doctors still think that geographic atrophy is a disease that happens on the border of the lesion. That is factually wrong. So far away from the border of the lesion, you can see the decline in retinal sensitivity occur long before the FAF lesion shows up. That's number 1. Number 2, everybody knows that the lack of foveal or the foveal sparing and ultimately the encroachment are of course a feature of this disease and make BCVA arguably a poor endpoint. But the piece that I think has been most underappreciated is that the ability to refixate is very individual. So you can have a fast progressor who's a good refixator who has better BCVA outcomes than a slow progressor who's a poor refixator, right? So that's something else that we're unpacking because it disconnects the BCVA decline from really the progression rates of the disease and allows us to really rethink how that mapping plays out. And then last but not least, I'm really looking forward to exploring what we find in wet AMD. Because in wet AMD, we've all gotten used to really relying on best-corrected visual acuity, on central retinal thickness, and obviously the amazing difference that we make in the lives of patients. But all of you know that when you see these patients, they all tell you, my vision's getting worse. How do you quantify that, right? So I suspect that when we're going to start looking at sensitivities in wet AMD patients, we're going to be surprised by the impact that the disease has beyond what we see with simply drying up the eye and stabilization of BCVA.
Super cool. I'm very excited about what you said about the augmented reality component of the technology because I don't think, as of right now, microperimetry is not widely available to have. So to have a tool to show the patient that, okay, it's not just visual acuity, we have these other markers that we can show you, number 1, and number 2, to get buy-in from the patient's family members. Because one of the big things is, for some of these patients, it's like, all right, look, this is, before we had nothing. Now we have these treatments. This is what the data shows. There are these, very small risks, but generally, they're safe. And our goal is to slow. I always tell patients that we're not going to undo the damage that's been done, but that's not really a compelling case, right? How do you make a compelling case? And this technology, I think, is very promising. Also, people have to go from following up every 3 to 6 months, depending on the doctor, I think, usually, to every 1 to 2 months. So that's more visits. It's a big commitment for the patient and their family member. So to be able to get that buy-in, I think, is huge. The other follow-up question I have for you is, what's the next frontier? Especially because you mentioned, all right, intermediate AMD. I have a bunch of patients with just PEDs, maybe a little bit of vascular activity on OCTA, but they're complaining of visual acuity loss or subclinical CNV, for example. Do you see some role there? First question. Follow-up question is the next frontier trying to find those patients without GA? I know we have a specific indication because how do we get to a point where we're not even getting the GA? Because clearly there's a disease process that's there. So I'd love to hear your thoughts on that.
Yeah, that is of course, I think the holy grail here, right? I can tell you that when I have geographic atrophy, I want to be treated in my first eye when it's affected very early on in the disease. And the reason for that is that, I know the data intimately well, and I know that treating early is better. There's the neuroprotective effects, etc. But I think that to be able to go there and to be able to convince patients what they're really getting into, right? We need more of a cohesive story, right? So that means visualizing again to the physician, to the patient, what they have, where they're headed. And for example, with this OCTF technology, because it relies on OCT and not some new technology where you're going to look at a decade of accumulated, right? You can go back in time. You can use large language models to go and look at OCTs. And I think with time, really accurately predict, even in a patient without historical OCTs, first image and be able to say, this is where this lesion is headed if you don't do anything. This is where this lesion will head if you do something. And then to be able to track that over time. I think it will open an important segment. And as I mentioned, I think in wet AMD, it's done miracles for our patients, of course. But to be able to to look beyond what goes on centrally in the retina and understand much better the broader macula, I think is going to be incredibly exciting.
Yeah, super cool. Do you think tell me about talk a little bit about the 5-year data, because I think that's pretty interesting. Because whenever I talk to people, for example, if you think of cancer studies, right? You have all those Kaplan-Meier survival curves. And honestly, personally, I don't treat juxtafoveal lesions. Even if there's a foveal lesions with 2100, 2200 visual acuity, I know that lesion can get larger. So, there are patients who are motivated to treat, especially with what's going on in the other eye. But with specifically, until we have, really good established markers that we can track, what I'm excited about is, is there something where we can show like, all right, these are the treated patients, sham-treated patients, these are the untreated patients. This is the survival curve, and the survival, instead of like mortality, what we're looking at is time to, for example, count fingers vision, or time to a drop in vision beyond a certain threshold, because that's a compelling case to seeing those two curves. That's, even in the absence of reliable functional markers, and the FDA wants that, everybody wants that, that's what everybody's talking about, and like trying to study is so many posters about that. So I'm excited to hear your thoughts on what that data will show.
Yeah, so it will be it will be presented early next year, right? I want
to know now.
I want to know now too. But look, it's just an incredible data set that allows us to explore all of the things that you said, right? So we'll be able to look at OCTF, at decline in central vision. All of these things coming together, and we're going to have years of analysis that we can do here and learn from this data set. Yeah, I think it's just the one thing that I find kind of really remarkable that we know already now, we don't need to wait for the 5-year data, is how powerful Syfovre is at protecting photoreceptor cells, right? So we know that in patients that go on treatment, the photoreceptor cells immediately stop dying, right? It is only when the RPE cells, typically have a smaller scotoma than the photoreceptor cells, when those catch up with the photoreceptor cells, that the photoreceptor cells will start dying again. Probably because they're not supported, rather than dying from the process itself. And that for us also kind of mechanistically is fascinating, and we have a phase 2 clinical trial with the so-called 3007 program, whereby lowering systemic levels of C3 by 90%, which we know we can do safely. And we're going to try to have that extra impact on the RPE cells to hopefully have a treatment that can go well beyond what we already have today.
That's cool, and this is from some of the initial work that you guys did with the systemic treatment. Bringing
right.
it all back.
Yeah,
inspiration.
It's been a lot of fun. It's been, and I'm glad you mentioned that, because often when I speak with you or your colleagues, right? That knowledge, the things that we have learned systemically, are so relevant to what we do in the eye, right? Mechanistically, why is complement a problem in the retina? We have a lot of ideas around that we learned from what we did systemically. Again, the role that complement plays in immunology in general, super fascinating stuff, and cross-pollinates quite well.
Super cool. Well, awesome to hear from the source on the story of complement, past, present, and future. Super exciting times. Thank you so much for your time, and looking forward to the future of complement.
Well, thank you so much. This was really fun, and invite me anytime. I'll come back.
Next year.
Thank you.
Thank you, everyone. Tune back in for another episode of RetFix and Chill. Thank you.